All right, so we're talking tonight about corrosion prevention. Our company name is Cocoon. Our tagline is Mastering the Elements. To us, that means protecting high-value assets from the elements. One of the first projects we started working on, well, let's talk about the government stuff first. So the government has a $20 billion annual loss to corrosion every year. So one of the things we took on with the 160th and the AMCOM Corrosion Program Office was establishing a new protective cover for equipment that's sitting out in the theater. This is one of the problems that equipment in theater is having a problem with. This is a very fine sand that affects your equipment. That sand is 1 micron. This is the state of protective covers today. The left pictures that you're seeing are covers that are not air permeable. So they actually trap in heat and moisture that causes what you call a greenhouse effect or a microclimate. To your right is a cover that gets way too heavy and in itself tears or causes corrosion on the weapon system itself. So we were asked to take this on about 8 years ago and develop a new textile working with 160 at the AMCOM Corrosion Program Office, and they set up some new standards. So the very first thing that we started to do when we were working with protective covers was try to figure out how to make a textile that was air permeable. So this demonstration shows you air here and water here. You're seeing that bubbles go through it very, very easily. This is demonstrating how air permeable this textile is. This also filters down to 0.3 microns. That sand in theater is 1 micron, so it's actually filtering out that sand. One of the other issues that we found as we were developing the textile is that protecting your optics and your windscreen was critical. So it was developing a textile that would not scratch. So this textile actually polishes when it's on your systems, and it won't collect and hold on to that sand and turn into a sandpaper. The other issue that was discovered is that covers that absorb water get way too heavy, and they also freeze. So this textile is hydrophobic, so it won't take in any water. Putting your covers on optics, electronics, rotary wing is an issue if you have a static charge on it. So this textile now has to be inherently anti-static. The way that our company solved the problem is that we imprinted a carbon print into the textile that is inherent to the textile, so it will never lose its anti-static capabilities. The other really interesting issue is when you got into textiles is that a textile that's put on a weapon system or a system that has fluids will absorb that fluid and become contaminated. So this textile has to be oleophobic so you can actually wash it and decontaminate it. This slide is showing you some corrosion tabs. Cocoon is the upper left hand on that tab. The rest are traditional covers. You're seeing a picture of a Black Hawk that is showing you how a cover sometimes goes on where the opening of the cover is not on the bottom but on the side. So even when water gets behind the cover, this material is so air permeable that it offloads that moisture content and prevents corrosion. So pretty much anything that now that is flying or is ground support equipment is being covered. It's beginning to be a standard requirement, and they're starting to use this type of technical textile to do it. These standards were developed by the AMCOM Corrosion Program Office. We meet or exceed all of those standards. All of these covers are designed by the user themselves. The cover of this material was passed by NOSA, Naval Ordnance Safety and Security Activity, to go on ordnance, and it has been approved by the AMCOM Corrosion Program Office. So what you end up with is a cover that is pretty unique in its capabilities, and it's called a technical textile. You have a cover that is extremely air permeable to offload that microclimate or the greenhouse effect to prevent corrosion. You have something that is inherently waterproof, so driving rain won't go through it. You have a textile that's hydrophobic, so it won't take on water and therefore it won't freeze. It filters out very fine sand, it's scratch resistant and washable. So that is a protective cover on how you go ahead and protect equipment sitting outside. If you can't protect things outside and you can put it inside, that is a better way to go. The things that you might want to know is that mold and mildew and insects start at 70% RH. Softening and packages start around 55% RH. Metal products corrode at 50% RH, and contact corrosion starts at 40% RH. So if you can store things in 35% RH or less, you've pretty much stopped corrosion. This is what the problem looks like in containers. This is what it looks like in yard part storage containers. Your upper left is a Chinook transmission worth about $500,000 gone to heck. So we take that on. This is pictures of our Army preposition storage afloat. These ships go to sea for 5 years at a time. Anything in that ship is in war-ready condition during that time. You do it ashore. This is what a corrosion-free storage facility looks like ashore. This is for cargo helicopter. They've put up 5 of these buildings so far in different locations. They're putting about $20 to $30 million worth of aviation parts in here with 0 losses. This is something in Okinawa. I like to show this one off. This is for the Marine Corps doing their parts storage. This passes international building codes and Typhoon. This passes 220-mile wind loads for this. Storing aircraft, the Marine Corps and Navy Air call it level 3 aircraft preservation. The interesting thing here is they call it stopping the aging process. So if an aircraft goes into this facility 2 years old, stores for 5 years old, it stores for 5 years, it comes out as 2 years old. This is what we're doing for ground support equipment also, and this gets us into our hangar business. So we take that technology and we also use fabric buildings to build hangars. This is something we did for this community out in Yuma. This gives you an idea at Fort Rucker with a full fire suppression system. This hangar all up is only $2.5 million, has a 20-year lifespan to it. This is something that we've done in Afghanistan, or one of the first that we've done. The interesting thing in this picture is you're seeing the LAM, the large area maintenance shelter, in front of it. You're all familiar with the failures that you have with that. This is how we redesigned that building with the help of 1/60th. This has now a flat end door that rolls up. We call that the SOAR door. Durability is a big issue for these type of facilities, so this is just kind of a fun thing showing you something we've done with NASA. This pulls away in 30 seconds and launches and gets reused over and over and over again. The last thing that we're doing is we're developing some new products for using our textile. We've just developed a new blanket for the Chinook. It is saving about 30 pounds, 70 pounds when you compare to new, but when you compare used to used blankets, we're saving about 80 pounds, 180 pounds, and we've improved its performance about 60%. So at the end of the day, you're looking at Cocoon. If you're going to look to protect your equipment, if you can cover it, there's a certain way you can do it. If you can store it inside, you stop corrosion altogether. And that's Cocoon.
Anybody have any